Hey guys, what's up? So I welcome you all to my channel Small Steps Academy, and today we are going to discuss golden rule steady state level of capital, also known as golden rule level of capital. Okay, so in the previous class we discussed about how saving affect the growth, right? And I told you that there will be only level effect if you increase your saving rate. There won't be any growth effect. But if you see here from this diagram also, you know what is their consumption. This is your consumption in this case when saving is this much, S1. When saving change, S2, your consumption is this much. So, and both are steady state level of capital, right? But there may be single steady state level of capital where this is maximum, right? This is maximum. So at that steady state of level, where what is this is consumption only. So at that steady state of level where consumption per worker is maximum, which it is called as golden rule level of capital, right? Where you maximize the consumption per worker, maximize small c or consumption per worker, right? It is that value of K star, steady state level of capital, where your C is maximum. Okay, and it is also denoted by K star gold, right? So to find steady state consumption per worker, what we are going to use? We will be using our national income accounting. Okay, so you know that income per worker is divided between consumption per worker and investment per worker, right? What I can write consumption here, C is equal to Y minus small I, right? And what can I further transform it? Y I can write equal to Fk minus I is equal to Sy. Okay, and again you can write in place of Y Fk, right? So this is your final consumption per worker function. Okay, so what does this final equation tells? It just tells that consumption per worker is the difference between output per worker and investment per worker. So since we want to find the steady state consumption, so we substitute steady state value of investment and capital. Okay, so now this is the common function, but now we have to find out the specific level of C where C is maximized, and there will be steady state of investment and output also. So I can rewrite this equation as C star is equal to F K star, right? At steady state level of, at steady state value, what are the value of C star, right? Minus S F K star. So you all know that at steady state your investment is equal to depreciation, right? What does it means? It means your F K star is equal to delta into K star, right? So you can again rewrite this as F K star minus delta into K star, right? So according to this equation, steady state consumption is what is left of steady state output after paying for the steady state depreciation. Okay, and this equation also shows one more thing, that increase in steady state level of capital, that is K star, has two opposite effect on steady state consumption. On the one hand, more capital means more output, right? And on the other hand, more capitals mean more output must be required to replace the depreciated capital, right? So now we will find out what is the maximum, sorry, we will now find out the maximized value of C star. Okay, so let's find out the condition. And you know how do we find out the condition? We simply derivate it first, then second derivate, then we see whatever happens. Okay, so this is your function. Okay, so I will differentiate it with respect to K star, right, which is equal to, what is this, fk star, and you know slope of this will be mpk, and this is delta. Okay, put equal to 0, so you get your condition this mpk star is equal to delta. Okay, now we can also verify this, that whether it is maximizing condition or not, by the second order derivative, right? If it comes negative, then this is your maximizing condition. D2 C star, right? D K star. Okay guys, so what will it be? You can see that you have differentiated this again with respect to K. So this will be slope of mpk star, right? And we know that it is less than 0. So, and how will it be 0? You know that if you have any function, like I'm saying that minus 2x square, okay, so what will be its slope? Its slope will be f dash x, right? What will it be? Minus 4x. And if you do it the double derivative, you already know that mpk is less than 0, right? So you don't want to see this, but let's imagine f double dash x is, what will it be? Minus 4. So it is obvious, it will be necessary that slope of this also, which is already negative, here also it is negative for non-negative numbers of x, so it will be also less than equal to 0. So your maximizing condition will be mpk is equal to delta, right? That is your depreciation proportion. That is the proportion of capital which is going to be depreciated. So now let's do one numerical, and then we will make we will plot all this in one diagram, that where do we get the K star gold. Okay, so I'm first doing the numerical. So you are given the aggregate production function is same, k to the power 0.5 and L to the power 0.5. Delta is given at 10%, our usual value, that is equal to 0.1, and it is asked in the question that find the steady state saving rate which is required to achieve golden rule level of capital per worker, right? So we first have to calculate in the form of output per worker, right? This will be, we have to divide it by L, this will be small y, and this we will come as root k. Okay, so now you know the condition is there, this mpk is equal to delta is already given, and if you derivate it with respect to k, you will get your mpk. What will be your mpk? 1 upon 2 root k star. Okay, and which will be equal to your depreciation rate, that is equal to 0.1. This implies you get your K star gold value. Whatever value of K star comes through this condition will be your K star gold, where your consumption per worker is maximum. Okay, similarly, corresponding to this K star gold 25, your Y star will be, if you put 25 here, you will get Y star is equal to 5. Okay, so now let's move on. But the question didn't ask this. The question asked that what is the saving rate corresponding to that level. So now we have to find out the saving rate, and we will just put our steady state level of consumption condition, which was S upon delta, if you remember my earlier class, K star upon F K star. So you have these three values, right? What are these values? This is S, this is 0.1, and we calculated K star from the before 25, and we got Y star, that is equal to F K star only as 5. Now if you solve this, you will get your saving is equal to 0.5, or you can say 50%. Now your question is over. You have been asked saving rate. So now if I want to plot it into diagram, what will be the diagram? Let's see. Okay. So in the x-axis, it will now come at steady state level of capital stock per worker. Why I have write down steady state level? Because we are finding the one level of from all the steady state level of capital which is supporting that as consumption per worker is maximum. That at which steady state level of capital our consumption per worker is maximum. That's why we are going to take steady state level only. That means that all the points on this x-axis which will be steady state capital stock per worker, steady state level, but there will be single point K star gold on which your capital will be maximized, and corresponding to this your saving rate will be different. Okay, according to that only. Here also you will write steady state output per worker. You know the three things come here. Investment per worker, steady state you have to write in all. Okay, and depreciation. Okay, we wrote the three things. Now what? Okay, so let's do. I'm just telling you the way of making diagram, because you have to make the slope of y star is equal to fk star is equal to delta. Okay, that is mpk is equal to delta. So first draw the delta k line. This will be your delta k star. Here all will become as k star because this is steady state level of capital. Okay, and corresponding to this you can draw your y star. Okay, so now you have to you know the condition is mpk star is equal to delta, right? So this is the slope of delta, and you have to make the exact slope here. Okay, that then only these both two slope will be equal. So it will be like this. You can just draw a parallel line according to this line, parallel to this delta k star. Okay, so you got this value, right? At this point the slope is equal, so you can draw a line over here, and this is your k star gold. So now you have to pass I star also, right? So you can easily pass I star from this point. Make sure you are passing this from this point. I star is equal to sy star is equal to sfk star. Okay, so this is your diagram. Corresponding to that you can calculate the value of depreciation. You have the saving rate which is supporting that k star gold. Okay, so we must note that economy doesn't automatically attain golden rule of steady state. If we want any particular steady state such as golden steady state, then we need a particular saving rate to support it. Okay guys, this was the main point. You need a particular saving rate to support that steady state level of golden steady state level. Okay, so this was all for today's class. In the next class we will see how there will be transition to golden rule steady state. Okay, that whether we are starting with too much capital or we are starting with less capital. So we will see how will economy adjust and come to again that point only, or what happens if we change that, what are the effects on y star, c star and I star. Okay, so that was all for today's class. If you have any doubt you can raise them in the comment section. So thank you guys for watching and keep posting your doubts. Bye.